Hey folks, welcome back. In this video we're going to look at band theory, so let's get started. It starts here by saying that in order to explain the electrical properties of materials, we can use band theory. Let's start by thinking about the atom. You've already seen this in National 5 Physics. So remember the basic structure of an atom where you've got the nucleus in the centre containing protons and neutrons that are bound together, and you've also got electrons whizzing around the outside of the nucleus in well-defined energy levels. So it says that in isolated atoms like the one above, electrons occupy discrete energy levels known as orbits. So these black paths here are known as orbits or discrete energy levels. And discrete just means they are well defined, which means they have a certain value of energy. And we can use something called the Bohr model of the atom shown below to visualize these energy levels. And this is actually introduced in the spectra section of the particles and waves topic from higher physics. So the Bohr model of the atom looks like this, where you've got your nucleus in the centre as a little dot, and then you've got something called the ground state, which is the energy level closest to the nucleus. And then we've got some excited states where there's only 3 being shown here, and these have been labelled as E1, E2 and E3. So electrons can occupy any of these energy levels. But what's more useful for us, and again this is shown in the spectra topic, is this thing called an energy level diagram. So this picture of the Bohr model of the atom can actually be redrawn in the form of something called an energy level diagram, where we actually take each of the energy levels, E0, E1, E2 and E3, and we draw it as a sort of ladder structure as shown here, where each line is above another. So there's our lowest energy state, E0 or E0, and that's the ground state, and then we've got the excited states, and all of these are separated by gaps. So we've got E1, E2, E3, and we've said these are the excited states. And then you'll notice that we have an arrow pointing down the way saying less energy, which means more negative. So that is because we actually define the highest energy level up here called the ionization level, which is when E is equal to 0 joules. So when an electron exists in the ionization level, it's said to have an energy equal to 0 joules. And that means because these energy levels are lower than that higher level, then these energy levels must have a negative energy. So that is why it says less energy pointing down the way. And why are we introducing this stuff in a video on band theory? Well, it says here that when atoms are brought together to form solids, their energy levels interact with each other and become grouped into bands. These bands represent a continuous range of energies that the electrons can have, but there are some groups of energy that are not allowed, and we call these band gaps. So just to show you a quick simulation of this, if we have a look at this energy level diagram down here, right now we've got the energy levels that the electrons can occupy, and we've also got forbidden levels, which are just the energy gaps known as band gaps. And right now we've got these set up for an isolated atom. So this is the energy level diagram for, say, one atom on its own, and these are the energy levels within that atom. However, what happens when we combine atoms or push atoms together to form a solid? Well, you'll notice as I move the slider here, going from an isolated atoms to a solid, our energy levels get formed into bands known as energy bands. And that's because the electrons in this whole solid material now can exist in these energy bands. And we still have forbidden levels or band gaps where electrons cannot occupy. So going back to the notes now, we've got the picture of what we've just seen. So we've got our energy bands here where electrons can occupy, and we've got forbidden levels or band gaps. And it says here that generally electrons will fill up the lower energy bands first. So this would be your lower energy band down here, and the next lowest would be this one, and then this one up here. So electrons will typically try and fill up the lowest energy bands that are closest to the nucleus of the atom first, and then we'll start filling up the upper energy bands once the lower ones have been filled. Also notice that as the atoms are pushed together, the greatest effect is on the outer, known as valence electrons, i.e. those in the highest energy levels, and this is the largest energy band on the diagram above. So here is our largest energy band, which we actually call the valence band, and this is because it contains the outer electrons known as valence electrons, which are the electrons in the outer shell of an atom. So we've started to introduce band theory here by talking about something called the valence band, and another band actually exists above the valence band which electrons can move into when they gain energy, and we call this the conduction band. Now notice on the diagram here we've not got a conduction band, but it would exist up here above the valence band. And we're saying that the conduction band is the band that electrons can move into from the valence band when electrons gain energy. So here's some definitions for these two new terms just to make them a bit more official. So we say the valence band, first of all, is the band that the outermost electrons can occupy. Electrons will jump from this band into the conduction band when excited, i.e. when they gain energy. And this could be through the material being heated up, it could be through the material being exposed to light, or the material could be doped. And again, we'll come across doping in a different video. We've also got the conduction band, which is the band above the valence band. Electrons can jump into this band from the valence band when they have enough energy. It is not completely full of electrons, meaning that electrons can move freely. This means that the band can conduct when an electric field is applied, or a potential difference. So in order for conduction to take place in a material, there needs to be space in the conduction band for the electrons to actually be able to move freely in it. Because if the conduction band was completely filled, then electrons would not be able to move. Lastly, it says the diagram below shows the conduction and valence bands in a solid material separated by a band gap. So let's say we've got a band gap here between the conduction band up here and the valence band down here. So electrons will move from the valence band across the band gap into the conduction band when they are excited. And it's the movement of electrons inside this conduction band when it's not completely full that is going to lead to conduction. Lastly, a top tip for you is that if asked to describe or explain how something works using band theory, then you must use the terms valence band, conduction band and electrons in your answer. So if you see these keywords using band theory, describe or explain something, then just make sure you use all of these keywords. And by doing that, you are using band theory. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a like, subscribe to the channel, and I'll see you in the next one. Take care.